Hello, I'm Cornell Douglas, and this is my math regression project for Mr. Porter's class. I am an EET major, and my project is about the energy usage of coal over the course of 160 years, starting from the 1850s. So this leads up until 2010. The reason I decided to pick coal instead of just electric energy in the United States was because I couldn't find any solid data for energy in the United States over a long period of time instead of just the amount of energy we burn in 1 year. And usually when I did find it, it was multiple things like how much energy you waste on your TV, how much energy you waste on a fridge, stuff like that. None of it like solid together in one lump sum like I wanted. So I just went with the next best thing and picked coal. Here's my data. As you can see, it starts in the 1850s and it adds on 20 years after that. The reason I picked that was because if my numbers are too big, it would cause problems for my calculator. And coal is measured in quadrillions, as you can see right here. And our rate of change is 8.9 year per coal used. At the end, we'll fix that to make it more understandable. My regressions, my cubic regression and my quadratic regression. I like my quadratic regression more than my cubic because my quadratic is more understandable than my cubic one. And when you zoom out, my cubic looks nicer, but for this project, we have to use the cubic regression. Oops, sorry, I meant my quadratic regression looks nicer than my cubic. And as you can see with my cubic, I couldn't really find any max or mins because it's just one straight line shooting off infinitely upwards, infinitely increasing. And if you go to the left, it's infinitely decreasing. My regression split, my left side is cubic and my right side is quadratic. Uh, I found the values of both lines at the point of 80. Sub- Subtracted them from each other, got a difference of 1.048. Raised the left side by 1.408. And I now have a continuous graph, as you can see right here. I also did a derivative split. At 80, you can see a very small break right here. But when I try to raise, no, lower the left side to make our graph continuous, it ended up making it have an even larger hole in it, and I couldn't figure out how to close it. Our concavity of our graph, concavity. After 0, it's concave up, pretty much. So it's increasing upwards, and after 0, it's pretty much concave down. So it's decreasing infinitely. And for our area under our curve, I'm going to be using a virtual TI-83 because I think it's easier to use that than to try explaining it with pictures. Here's my virtual TI-83. Turn it on. As you can see, I've already put in the data. I'm going to second quit, stat, calculate, and hit 6 for cubic, hit enter. Oop, mismatch. Let's see where that error is at. I forgot to put in my point for night for 160. That's 18.2. 40 is 19.6. and this is supposed to be 11. Enter. Okay, now that our data is fixed, we're going to second quit, stat, calculate, 6, get a cubic regression. There we go. Hit y equals vars 5 over regression equation. Then we're going to graph it. As you can see, oh wait, make sure you turn your stat plot on. That's on, graph it. Zoom stat. We can see our graph. Now we're going to second calculate 7. Now we're going to find our area under the graph. We'll make our lower limit 0 and our upper limit 160. Hit enter. We get 1,889.523 year per coal used. To make this data more understandable, we're going to divide the amount that we got by the number of years to just give us an average amount of how much coal we burned through a year. So we're going to second quit, clear that out, type that in, 0.523 divided by 160. We end up with 11.81, if you round up, 81 quadrillion coal burned a year. That is the end of my regression project, and I hope you guys liked it. Have a nice day.